All right, I think I'm finally recording here. We're going to deal today with what are known as standard and non-standard cells. When you're dealing with standard cells, the voltage equals E naught. The concentrations of all solutions are 1 molar. And the partial pressure of all gases is 1 atm. And temperature is 298 Kelvin. When we're dealing with non-standard cells, the most likely change is that we've changed concentrations. And when we've changed concentrations, we have changed the tendency of a reaction to proceed in the forward versus the reverse direction, kind of like Le Chatelier's principle. And we get a new voltage, which notice the absence of the little circle thingy. That means it's not going to be the same as E naught. It can be greater than, it can be less than, depending on what we manipulated. There's two different ways to look at this. We can look at it quantitatively using something called the Nernst equation, and we're going to be able to look at it in terms of Le Chatelier's principle as well. The Nernst equation is given as E equals E naught minus RT over NF ln cubed. Excuse me. Or more typically, if we haven't changed temperature. So what this means is if Q is less than 1, then ln of Q is negative, and we're going to have an increase in voltage. Because this whole second term, if this term is negative, then we're going to be minus a negative, which is going to be an increase. So then obviously the converse, if Q is greater than 1, ln Q is positive, and we're going to have a decrease in voltage. Another way to think of this is in terms of Le Chatelier's principle, but that'll make more sense once I give you an example. So let's say we're given this example. Ag plus zinc solid gives us, sorry, there should be a 2 here, gives us 2Ag and Zn plus 2. I calculated E naught from cathode minus anode and got 1.56 volts. For this reaction, K is equal to the concentration of zinc ions over the concentration of silver ions squared. And I'm going to exclude the zinc solid and the silver solid from this. So Q is done as the same way, just it uses whatever our present or initial concentrations are. So what would happen to the cell voltage if I increase the silver concentration? The easiest way is honestly Le Chatelier's principle. If I increase Ag plus, we are going to get a right shift. If the forward reaction is more spontaneous or more favored, that's going to give us an increase in voltage. A left shift or the reverse reaction being more favored would be a decrease in voltage. Or I can look at it in terms of Q and K. If I increase Ag, which is right here in the denominator, that's going to decrease my Q to less than 1, which was predicted by the 1 molar concentrations, which would give us an increase in voltage, same as we talked about on page 1. Okay, for B, decrease Zn plus 2. Think of it in terms of Le Chatelier's principle. If I remove some of this, what does the reaction have to do to replace it? It's going to shift right. Once again, that's making the forward reaction more spontaneous, which is going to give us an increase in voltage. If we do two things at once, like in the case of this, I change the concentration of silver from standard and I change the concentration of zinc away from standard. It would be easy for me to calculate the new voltage. I could calculate the new voltage using the Nernst equation. Sorry, that should be over N, not over Ln. E would equal My standard cell voltage I found out earlier, 1.56 volts. Minus 0.0257. N for this reaction would be 2 electrons being crossed out. ln of Q, 1.3 over 1.2 squared. If you calculate this, you will get a number that is indeed less than 1.56 volts. Earlier, because I didn't have a calculator with me, obviously, because I'm me, I calculated Q, and Q comes out as 0.9. So Q is less than 1. This quantity is going to be negative, and we're going to get an increase in voltage. Okay, another thing you can be asked is what will happen if we let to the voltage of the cell if we let it run a while. Again, I copied and pasted this in correctly. So if I were looking at the voltage of a cell over time, it's going to start off at E naught because that is the only point where the concentrations are actually 1 molar. Over the course of time, as this reaction proceeds, more and more and more of this is going to be made, and that's going to be increasing as this is consumed and that value is decreasing. So over time, the voltage of the battery is going to diminish, which is logical. So we're going to find that we would have some sort of decay as it approaches 0.